two concurrent schedules, that T1 before completion of the T1, if T2 has been started, then how we can compute whether this is meeting with the serializable schedule? As the results it means that the values of A and B after the concurrent schedule, whatever the values are, the same as that of the one of the serializable schedule, it meets. And hence we can say that this concurrent schedule is equivalent to the any schedule, that is serial schedule, and that's why this schedule is called as a serializable schedule. Serializable, it means same as a serial execution of the transactions. So this example and this computation we have seen yesterday. Now we are moving towards an example which will give us that all concurrent schedules cannot be serializable schedules. Still people are joining. So now let us compute about this example. So I hope as per this example, you might be able to compute the values. So I will go through this value, that is next example. But my request is that first you attempt at your level, whether the both values or whether whatever the final output is it same as that of the any serializable schedule, and then we can proceed with the actual computation of this value. Please go through this computation within a 5 minute, then we will go for the solving this example. Let me know the values of A and B after the execution of both transactions. Solve? Anyone? What is the value? At least anyone?
Ma'am,
Yes.
same value is getting like what means what is value of serial schedule and means ma'am both having the same value like A 1755 and B 1245.
In this example also, schedule 4, whatever current schedule I'm showing you, for that you got the same values. Uh, okay, let me go through the example and let us see how to calculate the values. Okay, so actually yesterday we have seen this. Am I clearly audible to all?
Okay.
Clearly audible?
Yeah, ma'am, you're clearly audible, but same value is getting, ma'am.
Okay, okay. Let us start with the computing the value. Okay, so initially whenever I'm starting with the T1, these are the two values, A equal to 2000. So here at this point I don't have instruction to, it means these are the initial values. Okay, it means before the start of my transaction, and hence these are before starting the transaction. So whenever my transaction T1 starts, at this point this will read the value of A as yes, A is having this value, so it will read this value as 2000. So whatever this 2000 value is there, that will be read by the transaction. Next it will perform the changes that uh, yes, A equal to A minus 50. So this will make A equal to 1950. Okay. So here this value is that updation is done. Now here at this point, after this we are having the next instruction to be read A. Now which value this T2 transaction will read? Which value this T2 transaction will read? Whether A equal to 1950 or whether A equal to 2000. Here, whatever the, yes, yes,
1950 means I have taken that.
yes. Here, the main difference is that whenever this T1 is executing, it had not yet written this value to the database. Okay, here whatever these changes are done, these are into a main memory only. And whenever we are writing this value, then only those changes will be reflected into a database. And hence, whenever read A, it means that This operation is going to read a data item A from a memory, that is a database. So this is not accessing any of the local copy, etc. This value is read from the database. And whenever write A we are executing, at this point, this updated value is returned to the database. Similarly, that concept get applied to the T2 also. So T2, whenever it is performing read A, okay, here, whatever this A's changed value is there, that is changed into a local space or into a main memory wherever my T1 is executing. Yet this value is not returned to the database. And whenever my T2 is starting, it is performing read A. It means that this is reading a value from the database only. And hence, because of this, whenever it is reading the value, it will read the older version of A. This will not read A equal to 1950 because yet this value is not written to the database. This is only available with the T1 transaction. Yet this value is not updated into a database, and hence T2 will read the old value, that is A equal to 2000. And hence this will compute that yes, right now we are having temp equal to A star. So let us compute the temp. Temp equal to A, that is 2000 multiplied by 0.1, sorry, 0.1, which is equal to 200. Okay. Next, this will make changes to the A equal to A minus, that is 2000 minus temp value, that is 200, equal to 1800. And next is a write A. So here this is performing write operation on the database. So this change will reflect on a database, and hence read write A. This will make or write A equal to 1800. Okay, this will be the updated value available into our database. And now at this point, this will again read that B equal to, initially before starting all the transactions, B's value was 1000. So this will read B equal to 1000. Clear with this explanation? Clear with this explanation why we have taken A equal to 2000? Because here T2 is a separate transaction and T1 is separate transaction. This has read value from the database. It has updated the value, but these updates are not yet returned to the database. Here, whenever this value or this transaction executes write A operation, at this point only, this will write the new updated value to the database. Clear with this clear with this explanation? Yes, no, any reply?
Yes, ma'am, it is clear now.
Okay, here unless and until we perform the write operation, these changes are not going to reflect on a database. And hence, unless and until write A, this is the only statement which is changing my database. And hence, whenever we are computing the values, always look for the latest write operation, and then only we can say that that was the recent update done on a database. Okay, so now this will write A equal to 1800. So this write operation has been done, and again after read B will make b b equal to 1000 because this was the older value. So here I will make that to the database. So this is writing new value to the database. And now here write A. So now in the local space of T1 has already read this value 2000. It has performed the changes. And now variable A is having the value 1950. So this write A will write the recent updated value, that is which is available with the T1, that it will write 1950 to the database. Okay, so this will write 1950 to the database. Now this has read B equal to 1000. So here also we are having read B operation. So this will also read as this was the initial value. So yet no write operation is performed. It means that the same value will be read here, and hence this will again write this as a, or this will again read the B's value as 1000, then perform the changes to the B. So B will be made as adding plus 50, 1050. So this will be the updated value. Write B. Write B, it means that this will write B equal to 1050 to database. Okay. So this change again will be done to the database. And this will save the transaction. So here we are having the final results of A and B, and A is equal to A is equal to 1950 and enter B equal to 1050 as our final answer. So these two are the final results of this transaction. Okay, so these two are the changes are done by the T1 transaction, and then we will come here into the T2. So T2 has read B equal to 1000. So the same value it will carry here. So here this will be making changes to the B. So B equal to B plus temp. So temp value is 200. So this will perform the changes, that this will add 200 to the current value, and which will be equal to 1200. So this will write B equal to 1200. So this will be the final write operation on the B, and hence this same changes will be done to the database also. Okay, so here after commit of this transaction, there is no any modification done on the A. So A's final value will be this, and B's final value will be 1200. Okay, so it means that right now we are having B equal to 1200 and A equal to 1950. Now let us check whether any of the schedule is having the same set of values. So this was the one of the serial schedule. A equal to 1750, not matching. B equal to 1250, no matching, because B is equal to 1200 is there. And here also in the serial schedule one also, neither A's value is matching, neither B's value is matching. It means that whatever this concurrent schedule is there, this is keeping my database into inconsistent state. This is not giving the result as that of my any of the serial schedule. Clear? Clear? Okay.
Hello, ma'am.
Yes.
Ma'am,
Huh.
I have understood the three state, but in the T1, okay, in the T1 means transaction, we
Hmm.
have only read the B. Okay, okay. Uh, we are also write the B on the database. So why we are not reading the 1950 here?
Actually, here write A operation is done at this step. Okay. At this point, write A operation is done as per the this statement. So this was the okay. Let us check out of these two transactions which is having the final write A operation. So this write it means as per the statements. So here this was the first write A operation. So this has written A equal to 1800 to the database. After that, this was the last statement which has performed changes to the database. Okay, so write A. After that, we don't have any modifications to the A. And that's why we are considering that this is the final write whatever the performed on the database. And this is the final value in that way. This was the write A operation, final write operation. After that, there is no any modifications on the A. Am I answering your question?
Yes, mom, yes.
Your question was regarding why this 1950 we are not writing to the database. The same was your question?
Mom,
Ah,
not A, it is B actually. Once we have written the B, okay,
huh,
on the data in the
huh,
database,
huh,
and we so automatically means it goes in database means
huh,
we have written actually. So why we
huh.
are not considering in the T2 transaction B's value like 1050?
Here because here already this T2 has performed read B operation before committing this. Here write B operation comes after reading the value of B here. Okay, I already told you that this is a time domain. Okay, as soon as I go on this, it means whatever the middle line is there, this is giving a time constraint. It means read A operation first performed, then A equal to A minus 50. Then T2 transaction executes in some another domain, and T1 and T2 are executing independently. They don't have common local memory as in the main memory. For T2, separate memory will be allocated. For T1, separate memory will be allocated. And hence, this will read a value from the database, and this will also read a value from database. So in the T2, already it has read a value from the database. Okay. It has already made a local copy for that B in its own execution space in the main memory, and hence the same variable it is using for the further computation. And after computation, this is performing changes to the database. Here this has written value to the database. Yes, write B operation is performed, but before writing only T2 has read the value from database. If consider instead of this, if we are having read B operation after this write B operation, then this would have read the recent value, just like here in the previous schedule. Here write B has been performed here, and after that this is reading a value B. Yes, at this point this will read a recent value. But in this example, this has already read this value B, and after that changes are done to the database, and hence whatever these changes are there, those effect will not be shown into or will not be seen into the T2.
Okay, ma'am, it's clear now.
Sure?
Yeah, ma'am, it's clear now.
Okay. So this was regarding the schedules which will keep our database into inconsistent state. Okay, inconsistent state it means that whatever this value of B, neither this is correct, neither value of A is correct, and hence this will leave my database into inconsistent state. So that's why we are desiring that whenever we are executing transactions concurrently, these always should keep our database into uh, a consistent state, and should be always concurrent schedule should be equal to the serializable schedule. Okay, this was the point that whenever we are executing the concurrent schedules, this should be always serializable schedule. So again, in case of serializability, there are number of types are there. Which kinds of serializability we can allow? That is what your concurrent schedules are there. On the few differences, there are types of the serializability are there. So let us see what is mean by a serializability. So when several concurrent transactions are trying to access the same data item, the instructions within these concurrent transactions must be ordered in some way as there are no problem in accessing and releasing the shared data item. So okay, here the meaning of this statement is that whenever we are having the common data item, just like in the previous example, we are having A and B. So here there should not be any problem in uh, reading the data and leaving the data or releasing the data item. At this point, only single transaction at a time should be able to access that member, perform the changes, and those changes should be visible to the other transactions. Okay, so there are two aspects are there for the serializability. First one is a conflict serializability. So conflict, it means that before that we need to it means uh, we need to see which are the statements that which can be called as a conflict operations. Okay, two instructions of two different transactions may want to access the same data item in order to perform read or write operation. Yes, we are having T1 and T2 and both are trying to access data member A and data member B, and both wanted to perform read as well as write operation on the A and B. Conflict serializability deals with detecting whether instructions are conflicting in any way and specifying the order in which two instructions will be executed in case there is any conflict. A conflict arises if at least one or both of the instructions is right operation. Okay, so here in the previous example, wait. So here we can see that out of this read A, this was the reading operation on the database. So this was actually affecting the database. A equal to A minus 50, this is a local operation. It means executed into main memory. So this will not have any changes to my database. Again, write A operation. This is also a database operation. So whatever these operations are there, whatever computation we are performing, these all are done into local, that is main memory. And only there are two operations on a database we are performing, that is reading A and writing A. So in case of simple transaction model also, we have seen that there are only two operations, even though there are multiple database operations are there, insert, update, delete, etc. In case of transactions, we are only limiting our discussion up to insert and read and write operation. Read, taking a data from database, and write, it means that writing those value to the database. So here we are considering our discussion, that is what your conflict serializability is there. Only two operations, read and write. So if consider out of these two transactions, here if both are reading the only data item, no performing the changes, it means that simultaneously at any time they can perform that operation. Right now we will take only single shared data item, that is A only we will take. So here whether T1 reads the value at the first or T2 reads the value at first, that doesn't make any difference because both are performing the read operation. So read operation doesn't make any changes to my database, and hence these two operations, order of these two, that is T1 and T2, doesn't matter here. The same is explained in the conflict serializability. Here, whenever there is at least a single write is there. Here, if consider, here read A is performed, here also read A is performed. So out of these two, who is reading the value? It doesn't get matter. A is also reading the value as 2000, and here also this is reading the value as 2000. So that doesn't make any difference. But who is making a final write operation? Okay. So if this is performing a write operation, this will make A equal to 1800. And if T1 is performing the write operation, this is making A equal to 1950. Okay, it means that here write operations are there. If consider this write A is previously done by T1. Okay, T1 is performing the first write operation, then database will be in some another state. If T2 is performing the first write or final write operation, database will be into some another state. So here the point here is that a conflict arises. Conflict, it means that whether to go for that operation or whether we can expect the same result, arises if at least one of the instructions is a write operation. If out of these two, that is two transactions are there, if out of these two transactions, if either of the transaction or both of the transactions are performing write operation, then conflict may be there. So let us see the four cases: read write, write read, and write write. So here it means that two transactions are there, Ti and Tj, that we will consider, or T1 or T2 we will consider. If two instructions, okay, the very first case, if two instructions of the two concurrent transactions are both for read operation, okay, T1 and T2, if both are performing the read operation, then they are not in conflict. Okay, there will not be any problem if either T1 perform first or T2 perform first. It doesn't make difference. Both are only reading the value and can be allowed to take place in any order. So if both are reading the value, then in any order we can allow them to read the value. Okay, so that was the meaning of first statement. And there will not be any conflict. That is, conflict, it means that multiple results will not be there, only single result will be there. Now the next case, if one of the instructions wants to perform a read operation, let us take T1 is performing the read operation, and other instruction want to perform write operation, and T2 wanted to perform write operation, then they are in conflict. That here there will be a conflict. Hence, their ordering is important. So here, whenever we are talking about this, so okay, I will skip to the writing mode so that you will understand. So I will take an example here. Okay, here only we will take. Consider that T1 and T2 are there. I will insert a table here. So right now we are willing to execute two transactions, and consider that uh, we are having A equal to 2000 only. Okay, so here I'm having T1, here I'm having T2. So T1 is performing read operation, T2 is also performing read operation. Okay, okay, now T1 is performing read operation. Here this one is performing write operation. Okay, here I am considering that the order of the sequence is first T1 is getting executed and then T2 is getting executed. Okay, and in this column we will consider that first T2 is getting executed and then T1 is getting executed. So okay, right now we are studying on this table we will make. So if consider both are performing only read operation, then previously the value of 2000 is there. If T1 is reading the value 2000, that will not make any changes, and T2 is also reading the value 2000, then also this will not make any changes to the database, and hence this will make my A equal to, this will remain same, that A is equal to 2000, and this also, and the sequence of the instructions, that is a sequence of either T2 or T1, doesn't make any difference. Now here consider that this is deducting minus 100 from a database, and this is performing minus 200 from a value. Okay, so both here also this is performing minus 200. Instead of minus 200, let us take that minus 10%. Okay, that we will take. So this will have a change in value. Okay, minus 10%, same as previous whatever we have taken. Okay, and write by using deducting 200. Okay, now here if both transactions are reading the value, so this will not make any changes to the database. So if consider this the second sequence, is this table clearly visible to you? I will increase the font, wait a minute. Okay, now here if consider first T1 is getting executed, if T1 is performing the reading operation, this will make my A equal to 2000 only, so this will not have any change, but here this will read A equal to 2000, that transaction will read the value A equal to 2000, and afterwards T2 is executing, so T1 will read the value as 2000, and for the T2 this will is deducting the value by 100, so this will make the value as 1900. Okay, so here T1 will not know that the T2 has performed any transaction. It means that the sequence matters. If consider here first T2 is getting executed. Okay, first if T2 is getting executed, T2 will make this value equal to 1900 as this is performing the write operation, and hence T1 will also read the updated value. Okay, T2 has made this equal to 1900 by deducting the 100 in the first sequence, and T1 will read the old value only. But if the sequence changes, that first T2 is getting executed and then T1 is getting executed, at this point it matters that because T1 has read the old value, sorry, here the T1 is reading the new value, it means this operation, that this sequence will have different effect on my database, and this sequence will have different effect on my database. Both the operations are not same, that in any order if I execute it, this will have an effect on database. Here in this case this will not have any effect as both are performing the reading operation, no write operation, the value of A remains as it is. But if here the sequence is getting changed, so this matters here, as if T1 is getting executed first, T1 will read the value as 2000, and if T2 is executing first, this T1 will read the value as 1900. Similarly, if consider T1 is getting executed first. So here this consider that T1 is performing deduction by 10%. Okay, it means that here T1 will make A equal to 1800 as 10% of 2000 is 200 deducting by that. So this will make the value equal to 1800 and as T2 is simply reading the value. So this will read the updated value as 1800. Whereas in this case, if T2 is executing first, this T2 will read the value as 2000 and as T1 is executing later, so T1 will be make my A equal to 1800. So here also we are having the difference. Here T2 is reading the value as 1800 and here T2 is reading the value as 2000. It means the sequence whether T1 and T2 is executed or T2 or T1 is getting executed, that will make a difference. And again, whenever it comes to the final write operation at this point, so if T1 is executing minus 10%, so this will make T1 equal to 1800. Okay, and T2 is again deducting the value by 100, so this will make T2 equal to 1800 minus 100, so this will make T2 equal to 1700. And if T2 is executing first, so T2 will read the value as 2000, will deduct the value by 100, so this will make 1900. Okay, this will make value of A equal to 1900 and T1 is deducting the value by 10%. So 1900 minus 190, 1900 minus 190. So this will make value equal to 1710. Okay, clear? Same is the value. Yes, same is the value 1700. So it means if how it means how my operations are getting executed, in which sequence they are executing, that matters a lot here. That we are trying to see here. So clear with this? Whether we are following this sequence or this sequence matters here, whether these transactions are reading the updated value or new value, and hence if there is a single write, okay, if both are read operations, then it will not make any will not make any conflict whether T1 is executing first or T2 is executing. But if either of the operation is write operation, either in this case or either in this case or either in this case, this will affect the database that it will not give the same results in case of these operations. So clear with this explanation, this example? Clear with this example so that we can go for the reading and understanding the remaining stuff. Okay, let us go to the this explanation. If two instructions of the two concurrent transactions are both for read operation, then they are not in conflict and can be allowed to take place in any order. Yes, if both are performing the read operation, we can allow them to, it means read or write in any of the order. So here this will not make any difference. Next, if one of the instructions want to perform a read operation and other instruction want to perform a write operation, then they are in conflict. That if either of the operation is a write operation, then there will be a conflict. Hence, their ordering is important. So here ordering is important. It means that if T1 and T2, this is the order, or T2 or T1. Results are based on the order because results may change as per the order. If the read instruction is performed first, then it reads the old value of data item, and after reading is over, the new value of data item is written. If the write operation is performed first, then updates the data item with new value and read instruction reads the newly updated value. The same point is being explained here. So here, if consider the read operation is getting performed first, we are having T1 first, that is read operation, and then write operation. So this read will perform the reading of old value only, and then this will be a write operation. And if consider we are having first write operation and then read operation. First write operation that performing deduction of 100, and then read operation that is reading the new value. So this will read the updated value by the T2 transaction. Okay, that is the meaning. If both the transactions are for write operation, then they are in conflict, that both are performing the write operation, but can be allowed to take place in any order. Here, it means we cannot restrict them to give this order or this order. So we can allow them to take in any order because the transaction do not read the value updated by each other. So here it is not, may not be possible that both are reading the updated values, and hence both might be performed reading reading of the values previously and then writing the new values. So in that case, the order also again matters. Who is performing the final write operation? So here, if consider that one transaction writes the value and another transaction reads perform changes on that, this might give a different result. The value that persists in the data item after the schedule is over is the one written by the instruction that perform the last write operation. So here it matters that who is performing the final write operation. Read these statements. Shall we move to the next point now? So here, let's
Ma'am, can you move on previous slide means at the starting of
this one,
serial? No, previous one. No,
last one, this one,
ma'am, theory of.
serializability.
Yeah.
This one,
Yeah, this one. Just wait for a while. I have to read it.
okay.
Hello, ma'am. You can continue. I have read it.
Okay, okay, okay. So next one is a okay. Let us say conflicts equivalent. So if consider both it means S1 and S2 two schedules are there, and then which containing the same set of transactions that I am having T1, T2, and another schedule also T1 and T2 is there, and we did the same result. Just like we have seen whenever concurrent schedules we are saying serializable, do two concurrent schedules S1 and S2, which is having same set of the transaction, maybe two, maybe three, maybe four, etc. And if both schedules are giving the same results, it means that whatever my data members are there, if their final values are matching, then we can say that these two schedules are conflict equivalent. Okay, so conflict equivalent, it means that S1 and S2 both are concurrent schedules. Okay, that is simultaneous schedules where these are giving A and B as the same value, same set of values for all the data items. Then we can see that these two are a conflict equivalent. Okay, and next one is a view serializable. So this concept is actually eliminated from the syllabus in the previous old syllabus, but in your syllabus again this point is introduced. So view serializable, it means that view, it means that the things like both are equivalent. Okay, they may not be actually equivalent, but this seems that both are equivalent schedules. Okay, so let us see what is mean by this view serializability. So this is another type of serializability that can be derived by creating another schedule out of an existing schedule involving the same set of transactions. Yes, here also we are having the same set of transactions, and some realization is there in terms of as compared to the conflict equivalent. So these two schedules would be called view serializable if whatever there are 3 to 4 rules, rules are followed while creating the second schedule out of the first. Okay, first schedule is there, and from that we are creating the another schedule. So two schedules, we can say that these are view equivalent or view serializable schedule. So if following rules are followed, so here these are the 3 rules which need to be checked. So let us see, let us consider that transactions T1 and T2 are being serialized to create two different schedules, S1 and S2, which we want to be view equivalent. Okay, two transactions are there, T1 and T2, and we wanted to create a view equivalent schedule. So schedule, it means that the way in which transactions are executed. Okay, so there is a S1 is one schedule, S2 is another schedule. So both T1 and T2 want to access the same data item. Okay, both wanted to access the same data item. Then in which case we can say that this is a view equivalent. Okay, so let us see. If in S1, okay, in schedule 1, T1 reads the initial value of a data item. Okay, so if in the T1, that is in the T1, that any data item is reading initially, then in the S2 also the same should be followed. That in the S2 also T1 should read the initial value of the same data item. Now this point comes, uh, it means seems like difficult. So, but we can go through the example. So here, this one is one schedule, that this is a one way of executing the transaction. And let us consider this one another only. So here T1 is performing read A, and in this schedule also T1 is performing the initial read. It means that this is my schedule 1 S1 and this is my schedule 2 S2. Then we are checking the first condition whether T1 is performing the initial read, or in the first schedule also whether T1 is performing the initial read. If both are performing the initial read, then the first condition satisfied. So now let us go for the another conditions. So next condition is that if in S1, okay, if in S1 T1 writes a value in the data item. Okay, some write operation is performed, that is write A operation is performed, which is read by T2. Okay, T2 is reading the value written by the T1. Then in S2 also, T1 should write the value in data item before T2 reads it. So this means that here in this example, if T1 is performing the write operation and that value is read by the T2, T2 is performing the read operation on the data item whose value is written by T1. So okay, this is my schedule S1, and in the S2 also, if T2 is reading the same value written by the T1. So here T1 is not performing the write A operation and still the value is read. It means that the second condition for this schedule S2 and this schedule S1 not satisfied. Okay. So second condition is not satisfied here. Here if this is in the schedule 1, if this is reading the value written by the T1, then in the S2 also, it should read the value written by A only. Okay, so this condition, second condition not satisfied for the two schedules. So then at this point only we can declare that these two schedules are not view equivalent. Okay, so now let us see what is the third condition. If in S1, okay, in schedule 1, T1 performs the final write operation, that T1 is performing the final write operation on that data item, then in S2 also, T1 should perform the final write operation on that data item. Okay, so in the S1 and S2 also, the final write should be done by the same transaction. So here we can go through not only A. So here write A, final write. Okay, I will go for the yes one first. So here final write A operation is done by the T2, but in case of this schedule, final write operation is done by A, and hence third condition also not meeting here. So this is how the view and view equivalency is checked. So first you go through the rules, read those rules for a while. I will show you, I will search for an example within 5 minutes whether any other possibility can be find out for the view equivalent. Let us go for the example. So this one is an example which will satisfy these two conditions. So here two schedules we have taken. So this is seems like equivalent to A and B. What are T1 and T2 we have executed, and serial schedules also we have seen. So this is a non-serial schedule S1 and this is a serial schedule S2. So let us check whether what are the conditions of a view equivalent schedules. Okay, the view equivalent says that if consider what same set of transactions, yes, we are having T1 and T2 here also in the schedule 2 also we are having T1 and T2. Now, if the first says that if in the schedule S1, if T1 is performing the initial read on a data item, in the S2 also, T1 should only perform the initial read. That in S1 also T1 is performing read X, and in S1 also T1 is performing the read X. Okay, that is done. And next for the Y also the same condition satisfies. No, for why we don't have this condition satisfied? Yes, satisfied. Here in S1 we are having initial read of Y done by the T1, and in S1 also initial read of Y is also done by T1 only. Okay. Now the second condition is that if in S1 Ti writes a value in the data item which is read by the T2, okay, it means first T1 is writing the data item and T2 is reading. Now let us check. Now here write X is performed by the T1 and the updated value is read by the T2. And in S2 also, before reading the T2 value, already T1 has written the value. Okay, it means that T2 is reading the updated value modified by the T1. And in schedule S1 also, the same condition satisfied that T2 is reading the value which is written by S1. It means second condition also got satisfied. Now let us see for the third condition. If in S1 T1 performs the final write operation on that data item. Okay, if T1 is performing the final write operation on that data item, in S2 also T1 should perform the final write operation on that data item. So here, final write in case of PS1 is performed by the T2. Here for the X final write is done by the T2, and for the Y also final write is done by the T2 in S1. In case of this schedule also, final write operation for the X is done by the T2, and for the Y also final write operation is done by the T2 only. It means that three of the conditions are satisfied. Now we can say that these two schedules S1 and S2 are view equivalent or view serializable schedule. Check for the three conditions whether these are getting satisfied or not. Now let us move to the next point, that is transaction isolation and atomicity. So what is meant by transaction isolation? Can anybody give me any understanding based answer? What is meant by transaction isolation? No. So transaction isolation, it means that whenever we are executing transactions in concurrent manner, that is concurrent execution of multiple transactions, then those feel that it means those transactions should be isolated from other transactions, and hence there should not be any overlapping of the same statement that both are executing right operation, etc. Okay, so isolation, it means that whatever transactions we are executing, these all should not access all the data items in the overlapping manner. These should be isolated. That simultaneously a single data item should be accessible by only one transaction. Multiple transactions should not be allowed to access the same data items simultaneously. Okay, at different time domains they can access, but simultaneous access is not allowed for the transaction. Okay, so here the condition might arise that if consider we are executing concurrently multiple transactions, then there might be possibility that one value uh, that is read by a transaction which is written by some another transaction, and because of some reason the previous transaction got aborted. Okay, for example, so this example we will consider, no, not this one, this one. Okay, here if consider that whatever the transaction T2 is there, this is reading the value, that is this is reading the A value which is written by the T1. Okay, and hence whatever the fate of this T2 is there, that is dependent on the T1. If consider because of some reason this T1 cannot commit, okay, cannot commit, it means that this transaction needs to be aborted and hence terminated. In that case, whatever these changes done to the database are there, these to be undo. It means undone the changes done by this transaction. If this transaction cannot commit, it means that whatever the effects done by that transaction are there, these need to be nullified, as we are having the atomicity property of a database. Atomicity, it means that either effect of complete transaction should be there on my database or none of the effect should be on my database. So already there is some effect done on the database and T2 is dependent on the T1. Okay, whenever it is reading the value right written by the T1 is there, then in that case we can say that T2 is dependent transactions on the T1. If T2 is nullifying its effect, it means that T2 also need to be abort, as this is reading the updated values from the T1. And hence, if this cannot continue with the completion of the transaction, this also cannot continue with the completion of transaction. So the same is done here. Isolation, it means that simultaneous access. At a point of time, only one transaction is accessing that data item, and hence after use of this variable A here, this variable updated value is passed to the T2, and we need to achieve the atomicity also. Atomicity, either effect of complete transaction should be on my database or none of the effects should be on my database. If in between T1 got failed, then T2 also need to be abort. So let us move towards the explanation. So if a transaction Ti fails, that right now we are talking about T1, for whatever reason, any reason can be there, we need to undo the effect of this transaction. Yes, whatever changes done to the database are there, we need to undo those changes to ensure the atomicity property of a transaction. So here either effect of complete transaction should be there or none of the effect should be there. In a system, in a system that allows concurrent execution, in a system that allows concurrent execution, the atomicity property ensures that any transaction Tj, okay, Tj it means we can consider T2, that is dependent on Ti, that is dependent on T1, that is Tj has read data written by Ti, T2 has read data written by T1, then is also aborted. It means T1, if T1 is getting aborted, T2 also need to be aborted. To achieve this, we need to place restrictions on type of schedules permitted in the system. So here we cannot go on, it means modifying the value. This might happen that here, this might happen that right now there are two transactions. This value written by T1 is read by T2. Again, there is another schedule, another transaction T3 is there, who is reading data item written by T2 and also reading the data of A here. It means that simultaneous access may result into, if this is getting aborted, T2 also need to be aborted and T3 also need to be aborted. So this can be a problem. So this results into a number of transactions to be aborted. So here for this purpose, we need to put a restriction on how this data item should be shared. Okay, so let us see which are the restrictions. So we address, so here to achieve this, we need to place restrictions on the type of schedules permitted in the system. So it means we can go for allowing or putting some restrictions on the schedules which can be allowed or which can be not allowed. So let us see which are those. So we address the issue of what schedules are acceptable from the viewpoint of recovery from transaction failure. So here we are, it means willing to write those schedules which can be recovered if there is a failure. So okay, first recoverable schedules. Which schedules can be recoverable? So partial schedule. So this one is a schedule where T6 and T7 two transactions are there, and here this is reading A and writing the value of A, and then T7 only reading the value of data item A and committing, and later on this T6 is reading the value of B, and because of some reason T6 got aborted. So now do you think that we can recover this schedule or recover this transaction? Here such type, here we cannot undo the effect of T7 because already transaction is committed, and hence committed transactions are complete transactions, and hence we cannot go for recovery whatever the loss that T7 has performed, that T7 has read the wrong value and already committed. Uh, yes, Nida. So let us see what is a definition of recoverable schedules. A recoverable schedule is one where for each pair of transactions Ti and Tj such that Tj reads a data item previously written by Ti. The commit operation of Ti appears before the commit operation of Tj. So this recoverable schedule says that if consider this Tj is reading the value modified by T6 or Ti, then whatever the commit of this transaction is there should be after the commit of this T6 only. Okay, the commit operation of Ti, the commit operation of Ti appears before the commit operation of Tj. Okay, so before committing T7 we need to commit the T6. Okay, that we can say that this is a recoverable schedule. Next, cascadeless schedule. Cascadeless schedule, it means that because of one transaction, if we are multiplying, we are aborting multiple transactions. Okay, so such schedules also we should avoid. So let us see what is the definition. A cascadeless schedule is one where for each pair of transactions Ti and Tj, such that Tj reads a data item previously written by Ti. The commit operation of Ti appears before the read operation of Tj. Okay, so in this case, we can say that these are the cascadeless schedules. So cascadeless schedules, even if a schedule is recoverable, it means we are having commit after the commit of Ti, and after that we are having commit of Tj. To recover correctly from a failure of a transaction Ti, if we wanted to recover the failure of Ti, we may have to roll back several transactions. There might be possibility of we need to roll back the multiple transactions, then in which a single transaction failure leads to a series of transaction rollbacks is called cascading rollback. So for this, I will show you an example. Wait a minute. So you can see this schedule that T8, T9 and T10 are there. So here T8 has written the value of A. That value is read by T9, which has written this value again. And that written value is read by the T8. Okay. And hence afterwards T8 is aborted. It means failed. In that case, this transaction needs to be rolled back. Roll back T8 as T9 has read the value that this read A appears after the write 8 means that T9 has read the value written by T8. So this transaction also need to be rolled back. And this T8 has read the value written by T9. As this is getting rolled back, this T10 also will be get rolled back. It means that single transaction failure, only failure of T8 has resulted into T9 failure and T8 failure. So such schedules are called as a cascading rollbacks. That multiple transactions we need to roll back, then this is called as a cascading rollback. So a phenomena in which a single transaction failure leads to a series of transaction rollbacks is called cascading rollback. So we need to avoid this. So for this purpose, a solution is that So we have to schedule Ti and Tj such that Tj reads a data item previously written by Ti. The commit operation of Ti appears before the read operation of Tj. It means that unless and until Ti get commits, Tj will not read a data item. Okay. So in this example, if consider here this unless and until T8 get commits, this T9 will not read a value. If consider this is abort, it means that this will read the old value which is not getting modified by the T8, and hence this will need not to be have a rollback. As this is reading the updated value, that's why it need to perform the rollback. If here instead of abort commit was here, then after the commit of Ti only, Tj will read a data item. Tj reads a data item previously written by Ti. The commit operation of Ti appears before the read operation of Tj. So this gives us a cascadeless schedule. Next, transaction isolation levels. Transaction isolation levels, it means that up to which level we can go for isolating the data items or isolating the database units, etc. So there are different levels of the isolation levels are there. So this is a lengthier points, and I think there are only 2 to 3 points remaining from this chapter. So regarding this, we will study into the next lecture. So let us revise what we have studied today. So today we studied about the serializability. Then we studied about the conflict serializability. So conflict arises whenever either of the operation is right operation. If there are only two operations, read operation, then there will not be any conflict. But either of the operation is right or both are right, then conflict can be there. And sequence of the instructions or transactions matters. This we have seen. Next, we have seen the three possibilities where these schedules can be different. Then we have seen the concept of view serializability, how two schedules can be said called to be view equivalent. So there are three conditions that same transaction in both the schedules should perform the initial reads. Then whatever the updated value written by some transaction are there in the schedule 1, and those updated value written by some another transaction, the same updation and reading of value should be done into schedule 2. And third condition is regarding the final write operation. So final write operation should be done by the same transaction in both the schedules. So these three conditions are mandatory whenever we are checking for the view serializability and view equivalence. And then we see example for this, and then we see why transaction isolation and how to achieve the atomicity. So atomicity, so transaction isolation, here we have seen that if we are isolating the data items and allowing the concurrent access, then a single transaction failure can lead to series of failure of transaction and need to be rolled back. So to avoid this, we need to have a commit transaction, and then only commit of dependent transaction should be after the commit of independent transaction. And another option we have seen it as a recoverable schedules, that how we can go for recoverable schedule. And also we see a cascadeless schedule. And what is mean by cascading rollbacks also, that because of single transaction, multiple transactions need to be rolled back. And to avoid this, a commit of that transaction, that initial independent transaction, and then remaining dependent transaction can read data item after the commit of independent transaction. So any doubt in today's lecture?